Assalamu alaikum. Bismillah ar-Rahman ar-Rahim. We continue integration. Last time we said about the step length h. If it is very small, it means we get good accuracy, less error. So how can we make it small? Well, so the idea is very simple. Just we use the property of integration. We want to integrate like from 0 to n here. Use the property of integration. This can be written from x0 to x1, and then plus x1 to x2 integration, then integrate from x2 to x, and so on. The last one, xn minus 1 to xn. So in that case here, this is here should be xn minus 1. And then so apply now trapezoidal rule to this here. This one, it means this is the trapezoidal for the first integration. The second integration, trapezoidal rule. The first value at here plus the value here, h divided, and so on until we reach the last one. If you take all of them, h over 2 outside, it is the same. And inside f0 here it is, and the last one fn. But look here, f of 1 times a half, and here f of 1 times a half. It means this plus it will be 2f1 times this one. And next one here, also plus the next one, and so on. So all of them in the middle are 2. But the first one and last one are not multiplied by 2. And this can be written like this. This is called composite trapezoidal rule, which means you can make h as small as you like. So what about the error now? Local truncation error. Local truncation error, here it is for each one. It's like this is the number. So if we write the local truncation for the first one, it's like this. Second derivative at eta 1, which we don't know, somewhere between x naught and x1. Then add the other error. Add all of them here. How many errors here? All of them are those one are in error. So we can write them instead of eta 1, eta 2, eta 3, eta in between a and b, we can write it eta and here n. And so in that case here, we will find eta here. This should be eta, in fact, not in eta here, between the smallest value and the largest value. So it is somewhere between A and B. So in that case here, so now we can find it easier. So if we go to next page now, so what is the error now? The error here it is. Here is n, and this was before, minus h squared times this one here. But here it is, we can use either n or h, so replace n by the value b minus a divided by h, so here it is. So here the whole error for composite rule. Or use only n, which means replace h by a minus a, b minus a divided by h, you'll get this one. Well, this one same as this one. So now we can know, depends on the value of n. Clearly when is in large, which means the number of subinterval are big, this becomes smaller, which means we reduce the error. Or h is small, same things. So now, what can we do here in that case? So just we repeat, what about the error for Simpson rule? It is the same idea here. Now this is Simpson rule, but again, what is Simpson rule? It should be even, because we need for each integration, we need 3 points. So n should be even. We write h equal b minus a divided by n, where n is even. So this is about Simpson rule. Just repeat as before. We make it some subinterval, but here not from x0 to x2, x2 to x4, x4 to x, and so on until the last one. Why we go 2 by 2? Because we need the 3 points for each integral to apply Simpson rule. So in that case, when we apply Simpson rule here, here is the answer. The second one, here is the answer. Times, don't forget, h divided by 3. And so on until you reach the last one. Just accumulate this one, make summation. We can see the first one and last one here are nothing changed. But here f2 from the first bracket and f2 from the second bracket. So it will be 2. Again here f of 4 with the second bracket, it will be again 2. So the even number, all of them times 2. But the odd number not change here. 4 times f1, 4 times f2, f3, and so on. So here times 4 times 4 times. All of this can be written like this here. odd number multiplied by 4, even number multiplied by this, don't forget to plus this. All can be written as summation notation. And the error here again, if you substitute, here we are, just take b minus a divided by n is h, here is the answer. So now h power 4 becomes times b minus a divided by 180. And we know what is it. So now we know what is the error, and we cannot choose n the way we like to make it as small as possible. So h or n here, don't forget h here equal, here is given somewhere, b minus a divided by n. So we'll go next slide to illustrate this idea. So now, for example, we would like to approximate from 0.5 to 1 sine 2x. How to do? Can we estimate? Because we'd like to learn how to estimate. Most of the time we don't know the function. We don't know whether it is integrable or not. So how to estimate the error here, the value of h? So here, like we said, find value of n. What is n? Such that the error is sufficiently small. So what is the error here? So he said wanted sufficiently small, correct to 6 decimal places. What does 6 decimal places mean? It means the error we would like it here, 10 power minus 6 times a half. This means the error should be correct to 6 decimal places. So it means I have to calculate this one here inside. How to do it? It means I need second derivative. Well, what is second derivative? Here is first derivative. Here is second derivative, so we have 4. The largest value for this, because sine is largest, is 1, so it is 4 times 1. So here we wrote it like this. So replace this one by 1. Here is 1, but 4 remain 4. What about this one here? B minus a. It is b minus a, which is written here, power 3, divide by 12 n squared. So we put it here. So we would like to have all of this here smaller than this. Why 6? Because the question, he said 6 decimal places. That was the question. And we have now this inequality which contains the unknown n. Well, just we have to solve it. Solve it is not difficult to solve. So solve this one here, and n squared greater than or equal this. If you use calculator, you find this one. It's not difficult. But here, what is n? It should be greater than this number. So what is the smallest integer which is greater than this number? It means 289. That's why he's put, because n should be integers. So that's why he put 289. We'll repeat the idea, but for trapezoidal rule. So here, before I forgot how many iterations we need to obtain the answer correct to 6 decimal places, we need 289 iterations at least. Okay, we'll see now for Simpson rule. Simpson rule, here's the error. So what is the error here? Let me do it now. Oh God, I don't want it to be large. So here it is. Here is the error. Again, we have to calculate the second derivative. This one we know, this one here. All of this here we know. Okay, so second derivative we found it before. Third derivative is here minus 8. Fourth derivative 16. So the largest value for this, the absolute largest value is 16, which we are going to put here. 16. Because this one we know. At most is 1. And what about the other one? The other one, just substitute. B minus a, this one 1 minus a half, and it says here power, it should be power 4, I think here it says. B minus a, or maybe put here h as well, which he calculated before. So that time here, divide by this. When we put this one now, again we have inequality which contains n, but n power 4. Solve this inequality, use a calculator, we find n greater than or equal this number, which means n should be at least 9, without thinking integer. The smallest integer, which is larger than 6.63, is 9. But because we are using Simpson rule, it should be even. So what is the smallest even number? It should be 10. So we have to choose n. Imagine now Simpson rule need only 10 iteration or 10 steps. 10 here, sub-interval, we obtain the answer correct to 6 decimal places. But the trapezoidal need 289 sub-interval to obtain the same. So for this reason, it is very clear now, Simpson rule, it should be used, which is much better than the other method. Okay. I'll stop here because I will continue again later on for another type of method. Thank you. Wassalamu alaikum.